What 30 days of healthy living really does to your brain, heart, and body. You've done this before. Day 1, full of fire, green smoothie, new gym shoes. A promise to yourself that this time is different. By day 9, you're exhausted. By day 14, you're back on the couch, telling yourself you just don't have the discipline. Here's the thing nobody tells you. It was never about discipline. Your body was running a hidden script the entire time, a biological one. And it had nothing to do with your willpower. Most people quit right before the actual changes begin. Not because they're weak, because they're human, and because nobody explained what was actually happening inside them, hour by hour, day by day. Stay with me, because once you understand this, 30 days stops feeling like a test of character. It starts feeling like a system you can actually win. Think of your body like a massive, aging factory. Every day, machines wear down. Waste piles up in the corners. Supervisors miss shifts. Everything still runs, just slower, dirtier, less efficient than it used to. That's you, most mornings. Now here's what's strange. The exhaustion you feel in week 1 of getting healthy, that's not your body failing. That's your body finally noticing the mess. Yoshinori Osumi won a Nobel Prize for uncovering a process called autophagy, literally self-eating. It's your cell's internal cleanup crew. When triggered, damaged proteins and worn-out cell parts get broken down and recycled. Most people never realize this cleanup crew is nearly dormant in a body running on constant snacking, constant stress, constant sugar. The surprising part is what wakes the crew back up. It isn't a supplement. It isn't a fasting app. It's a specific window of time, and inside that window, something in your bloodstream has been quietly working against you this whole time. And this is where it gets dark. That something is insulin. Every time you eat, even a healthy snack, insulin rises to shuttle sugar into your cells. That's normal. That's necessary. But here's what most people completely miss. While insulin is elevated, autophagy shuts down. The cleanup crew goes home. Repair pauses. Your factory keeps producing, but nothing gets fixed. Constant grazing throughout the day means insulin almost never drops low enough for cleanup to begin. This was never your fault. Nobody explained that eating 6 small meals a day, marketed for years as healthy, was quietly blocking your body's own repair system. Here's where it gets counterintuitive. The fix isn't more effort, it's better timing. Morning, delay your first meal by even 2 to 3 hours after waking. Black coffee or water is fine. Cortisol is naturally high right now. That's your body's built-in energy system. Let it work instead of overriding it with food. Midday, eat your largest meal here, built around protein and fiber. Eggs, salmon, lentils, leafy greens. This is when insulin sensitivity peaks. Your muscles absorb nutrients efficiently instead of storing them as fat. Evening, finish eating at least 3 hours before bed. This isn't punishment, it's permission. Permission for insulin to drop, for autophagy to switch back on, for your nervous system to shift out of digest mode and into repair mode overnight. Sleep is where the real construction happens. Growth hormone rises. The brain's glymphatic system, its literal waste-clearing pathway, studied extensively at institutions like the Salk Institute, flushes out cellular debris, including proteins linked to long-term cognitive decline. Skip that window consistently, and repair never catches up to damage. Here's what changes everything. None of these steps work in isolation. They stack. A slightly longer fasting window improves insulin sensitivity. Better insulin sensitivity means deeper sleep. Deeper sleep means stronger cellular cleanup the next day. Stronger cleanup means the next fasting window feels easier, not harder. By day 30, you're not fighting your biology anymore. You're finally working with it. Your heart isn't just beating, it's recovering. Your brain isn't just functioning, it's clearing. Your body isn't just surviving the day, it's rebuilding from it. This was never about willpower. It was about timing, and now you know it. But there's one more player in this story we haven't touched yet. A molecule your body makes less of every single year. One that determines how fast all of this repair actually happens. And once you see what it does, you'll never look at aging the same way again. What actually controls how fast your body repairs itself after 30? You've been doing everything right, eating in the window, sleeping earlier, watching the cleanup crew finally show up for work, and still some mornings you feel older than you should. Here's the thing nobody tells you. Timing wakes the repair system up. But something else decides how fast that system actually works. And that something has been quietly declining since you were 20. Most people never realize this. They assume aging is just time passing. It isn't. It's a resource running low. Stay with me, because this changes everything you think you know about getting older. Picture your factory again. The cleanup crew is finally showing up on time now. Autophagy's working. Insulin's behaving. But a factory needs more than a schedule. It needs power. Elizabeth Blackburn, who won a Nobel Prize studying the protective caps on your DNA called telomeres, showed something unsettling. Every time a cell divides, those caps shorten a little. Shorten enough and the cell stops dividing altogether. It goes dormant. Still there, just useless. Here's what most people completely miss. The speed of that shortening isn't fixed. It's fueled or starved by one molecule running through nearly every repair process in your body. That molecule is NAD+. And here's where it gets dark. Your NAD levels can drop by more than half between your 20s and your 50s. NAD isn't a supplement trend. It's the actual power source your cells use to run repair enzymes, including the ones that protect those telomere caps. Here's what happened next that surprised researchers. Low NAD+ doesn't just slow repair down. It makes your cells act older than they are, even when the rest of your habits are good. This was never your fault. Nobody explained that fasting windows and clean sleep only work as well as the power source behind them. So here's where it gets counterintuitive. You don't fix this by adding more effort. You fix it by protecting what little power you have left and rebuilding from there. Morning, skip the sugar crash breakfast entirely. A spike and crash blood sugar pattern burns through NAD faster, forcing cells to work overtime just to recover. Midday, add movement, even 15 minutes of brisk walking. Muscle contraction directly triggers NAD-boosting pathways. This isn't about burning calories, it's about restocking fuel. Evening, include NAD precursor-rich foods like salmon, mushrooms, and edamame in your last meal. Small, consistent inputs matter more than occasional large ones. Overnight, protect deep sleep at all costs. This is when NAD-dependent repair enzymes do their heaviest lifting, repairing DNA damage from the day before it compounds. Here's what changes everything. Fasting improves insulin sensitivity. Better insulin sensitivity slows NAD depletion. More NAD+ means faster, deeper cellular repair. Deeper repair means your body handles tomorrow's stress with more power left over, not less. 30 days from now, you're not just eating better and sleeping better. You're running a body with more actual fuel behind every repair job it does. Your cells aren't just cleaning up anymore. They're recharging. But there's a second molecule working alongside NAD, one most people have never heard of, and one that may explain why some people age slowly while others don't, no matter how healthy they seem to be. We'll go there next. What your body's second repair molecule reveals about why some people age slower. Two people, same diet, same sleep, same fasting window. One of them looks 10 years younger than the other. Here's the thing nobody tells you. It's not genetics in the way you think. It's not luck either. It's a molecule most people have never heard of, quietly deciding whether your cells defend themselves or just give up. Stay with me, because once you see this, aging well stops looking random. It starts looking like biology you can actually influence. Think of NAD as the electricity running through your factory. Necessary, powerful. But electricity alone doesn't decide what gets built or protected. You need supervisors, someone walking the floor, deciding which machines get repaired first, which fires get put out before they spread. That's sirtuins, a family of proteins that act like your cell's internal supervisors, and they run entirely on NAD+ to do their job. Most people never realize this. You can have decent NAD plus levels and still age fast because your sirtuins aren't getting activated properly. Here's what most people completely miss. Sirtuins don't just clean up damage. They decide whether a stress cell fights to survive or quietly shuts down and stops functioning altogether. And here's where it gets dark. Chronic low-grade stress, the kind you've stopped noticing because it's just normal life now, floods your body with cortisol, and cortisol quietly interferes with sirtuin activity. Your supervisors go quiet. The fires spread. Nobody's directing the cleanup crew anymore, even if the crew itself is ready to work. This was never about being less resilient than someone else. It was about supervisors being drowned out by noise they were never designed to handle constantly. Researchers studying sirtuins, including teams connected to Harvard and MIT, found something that surprised them. Brief, controlled stress actually activates sirtuins. Chronic, unrelenting stress shuts them down. The difference isn't the stress itself, it's whether your body ever gets to exhale. So here's where it gets counterintuitive. The fix isn't eliminating stress completely. Some stress is the signal your supervisors need. Morning, 5 minutes of cold exposure. A cold shower's final 30 seconds is enough. This is a brief controlled stressor that activates sirtuins without overwhelming them. Midday, a short burst of movement that actually challenges you. Stairs, a fast walk uphill, 10 minutes of resistance work. Again, brief and intense beats, long and draining. Evening, this is where you exhale. No scrolling through conflict. No unresolved arguments replaying in your head. This is when cortisol needs to drop so your supervisors can come back online overnight. Overnight, deep, uninterrupted sleep is when sirtuins do their most important work, walking the floor, directing NAD+ toward the repairs that matter most that night. Here's what changes everything. Fasting protects insulin sensitivity. Protected insulin sensitivity preserves NAD+. Preserved NAD+ fuels your sirtuins. Active sirtuins decide moment by moment whether your cells repair or retreat. None of these systems work alone. They were never meant to. 30 days in, you're not just eating on a schedule and sleeping earlier anymore. You're running a body where the power source is protected, and the supervisors are finally back on the floor, directing every repair that matters. But there's one more piece to this. The actual messenger that tells your sirtuins when danger is real versus when it's just noise. And once you understand that messenger, you'll understand why some people burn out at 40 and others don't.